This is adding and subtracting fractions, part 2. Another definition, unlike denominators, are denominators of fractions that are not the same. For example, 2/3 and 1/2. Those two denominators are not the same. One's a 3 and one's a 2. So what we're going to do is we are going to change the fractions to equivalent fractions so that we can easily add or subtract them. Some strategies to do that are basically changing the fractions so that the denominators match. Another strategy is using cross products. Okay, so we are going to change the fraction to an equivalent fraction in these two examples. Example 1, we have 4/9 and we want to add to that 2/3. So what we're going to have to do is find a common denominator. In this case, it's going to be 9. So I'm leaving 4/9 the same, and I need to change 2/3 so that it has a denominator of 9. So what I have to ask myself is 3 times what is 9? And then I answer 3 times 3 is 9. So whatever I do to the denominator, I need to also do to the numerator to keep it equivalent. So if I multiply the denominator by 3, then I will need to multiply the numerator by 3. 2 times 3 is 6. So 2/3 and 6/9 are what we call equivalent fractions. They have the same value, they just look different. Now I can go ahead and add my fractions because now I have equivalent denominators, or the same denominator. So to do that, I add the numerators. 4 plus 6 is 10, and then I keep the denominator the same. I have 10/9, that's an improper fraction. Now I need to change it to a mixed number. I can pull out one whole, and I will be left with 1/9. So my answer is 1 and 1/9. Now, example 2, I'll do with you guys. So I have 4/5, and I'm taking away 1/3. I need to ask myself, what is an equivalent denominator or a common denominator between the numbers 5 and 3? And that answer is 15. So I need to rename these fractions so that they have a denominator of 15, and I'm subtracting them. So I have to ask myself, 5 times what is 15? 5 times 3 is 15, so 3 times 4 is 12. So again, what I did was just times 3 to get this new equivalent fraction. And then I'll do the same thing over here. 3 times what is 15? 3 times 5 is 15. So I need to multiply the numerator by 5 to make it stay equivalent. 1 times 5 is 5. Now I have like denominators, so I will subtract the numerators and keep the denominator the same. 12 minus 5 is 7. Once I have my fraction like this, I need to look to see if it can be simplified. In this case, it cannot be simplified any further. So that's my answer, 7/15. If I'm to add or subtract by using cross products, this is what I would do. I have 3/4, and I would like to add that to 5/6. They do not have a common denominator. But what I can do is I can take a look at the numerators and the denominators, and I can use cross products to find my answer. This is how I'll change the numerator. I multiply literally across the fraction. 6 times 3 is 18. And 4 times 5 is 20. And since I'm adding fractions, I'm adding those together. So 18 plus 20 is 38. That will be my numerator. For my denominators, I'm literally just multiplying 4 and 6. I just multiply the denominators, I got 24. So I'm going to put my numerator on top of my denominator and rewrite it down here. 38 over 24. That's an improper fraction, so I'm going to have to simplify it. I can pull out one whole, and I'm left with 14/24. And I realize I can divide both of these numbers by 2. So when I do that, 14 divided by 2 is 7. 24 divided by 2 is 12. I cannot simplify that any further, so my final answer is 1 and 7/12. You can choose whichever strategy you like the best. I personally like the changing fractions strategy, so I'm going to do that on the next couple problems. I think the reason that I like this strategy is just because I grew up using that strategy, and that's the one I'm most comfortable with. So let's go with question number 1. Now I've got mixed numbers. What I'm going to do is I'm actually going to change these fractions first. I'm not going to add the whole numbers because I might have to rename or regroup my fraction. So I'm just going to go ahead and change the whole thing right now. I've got 8 1/3 and 2 3/5. I notice that 3 and 5 are unlike denominators, so I'm going to have to change them. So I'm just going to rewrite this 8 blank, and then 15 is going to be the new denominator, and 2 blank with 15 as the new denominator. That's how I set it up, just so I'm organized when I get ready to multiply. So 3 goes into 15 5 times. 5 times 1 is 5. 5 goes into 15 3 times. 3 times 3 is 9. Now I can go ahead and add my whole numbers. 8 plus 2 is 10. And then keep the denominator the same. 5 plus 9 is 14. All right, I have that in simplest form. I can't simplify it anymore. I don't have any improper fractions, so it looks good. Number 2, I've got 3 7/8 plus 5 11 24. I'm going to go ahead and rename these fractions so they have the same denominator. I'm going to have to use a denominator of 24 because 8 goes into 24 3 times, and this one's already has a denominator of 24, so it's ready to go. So like I said, 8 goes into 24 3 times. 3 times 7 is 21, and this one gets to stay the same. Okay, now here's the fun part. I'm going to add my whole numbers. 3 plus 5 is 8. Keep the denominator the same, 24. And now I have 21 plus 11. 21 plus 11 is 32. And I've got a whole number and an improper fraction. Definitely going to have to fix that. So what happens is I pull out a whole number here. So I have a whole 1 to go with my 8. And then I'm left with 8 24ths. So altogether I have 9 and 8 24ths. But that 8 24ths can be reduced. I have to divide both of those by 8. So my final answer will be 9 1/3. So that took a lot of math, but taking it step by step, it's not too bad. In this third one, like I said, I'm going to have to rename this because I have 4 whole units for whatever I have for gummy bears, and I'm subtracting 1 5/6. So I have to change this so it has a fraction component to it. So I'm going to rename it as 3 6/6. The reason I changed it to 3 6/6 is because 6/6 is the same as 1. 1 plus 3 is 4. And I'm choosing 6 as my denominator so it matches the other denominator. This is actually a subtraction problem, so I'm going to go ahead and subtract. 3 minus 1 is 2. 6 minus 5 is 1. Keep the denominator. So my final answer for that problem is 2 1/6. I would like you to try some of these. If you get stuck, just rewind the video, rewatch some of the math that I did. Make sure you take good notes. Try these, show all your work. That's going to help you, and we'll talk about them in class tomorrow.